welcome to our channel Euclid Mathematics. It's really nice to see you all back here. So in my today's video, I'm going to explain to you all one of the previous year question from JEE Advanced. From last few days, I started solving latest JEE Advanced previous year question paper. Why we need these questions? Because we need to be familiar with the concepts, the way they are asking question, and how can we deal this question in a limited amount of time. So for this, we have to solve multiple and lot of amount of questions from JEE Advanced. Okay, so in my today's video, I'm gonna explain to you all one of the questions from JEE Advanced. Okay, so question it is quite easy. Just we have to understand what we have given and then follow apply our concepts over there. Okay, now let's get started with today's question. First of all, I'm gonna explain to you all detailed question and then we'll go for each and every option separately. Because of that, the question it is from the paper second section second. Okay, so that's why maybe multiple answer option correct there. Okay, so multiple answer correct option is there, so we have to check each and every option very carefully. Now let's get started with today's question. We have given function f of x is a sine pi x by x square. Okay, so this one is a function given f of x, and that function define only the value for x bigger than 0. Okay, x greater than 0, and the point x1 x2 xn and y1 y2 yn also define. Okay, so the point x1 x2 xn, it says that the point where you goes to xn, the point it is getting bigger and bigger. Okay, that means x1 less, strictly less, x2 strictly less, x3 strictly less, up to xn and strictly less, also on. Okay, and all these points it is coming from the local maxima. Okay, and similarly condition it is given for the point for y1 to y1. So it says that y1 strictly less, y2 strictly less, dash dash strictly less, yn. Okay, these all points are coming from local minima. Okay, so these two conditions are given in our question, and then we have to figure it out which one of the option is correct from between four options, because multiple correct question is there, so maybe one or more than one options are true. So first option it says that xn plus 1 minus xn, which is bigger than 2 for every value of n, and second option says that xn which belongs to open interval to n plus 1 by 2 for every value of n. Third option it says that modulus of xn minus yn, which is bigger than 1 for all values of n, and the fourth option it says that x1 strictly less, y1. Okay, so let's figure it out which one of the option is correct. Okay, because most of the questions from JEE Advanced you cannot solve it directly. You have to apply some graphical presentation or some application based part to our question, then and only then you can grasp this easily. Okay, concept easily. Nothing is difficult over here, but yeah, your thinking, way of thinking need to be a different. Okay, little confusing questions are these, but try to go for first of all given, and then let's plot the graph and go for calculations. So our solution, okay, our solution it is here. So f of x it is given sine pi x by x square, x bigger than 0. x1 to xn is having condition all are strictly less as we go bigger xn for all point of local maxima, and similarly for yn. Okay, y1 to yn for all point of local minima. Okay, that means it is given as a point of local maxima and a local minima for f of x. So how can we define point of local maxima, local minima? Whenever we want local maxima and local minima, we always substitute f dash of x, which is equal to 0. Okay, for finding the point of local maxima, local minima, always we substitute f dash of x, which is equal to 0. Okay, and then we find the f double dash of x, whether it is f double dash of x is bigger 0. If it is bigger than 0, then we say that local minima. Smaller than 0, then we say that local maxima. Okay, these are easy condition need to apply. So as we have f of x sine pi x by x square, now we want the f dash of x. Why we want? Because local maxima minima, we have to deal this condition over here. Okay, so f of x is sine pi x by x square, find out f dash of x. So as we can see here, it seems like that it is the part of quotient u by v form. So for finding f dash of u by v, so we apply quotient rule for differentiation. Okay, so quotient rule for differentiation, it says that v into derivative of u. Okay, that means f dash of x, we want the f dash of x. Okay, it says that v which is x square into differentiation of u. Sin pi x is having differentiation cos pi x and cos pi x, okay, and we differentiate that f of x further, so differentiation of pi x will be pi only, okay. So this is the differentiation for v into derivative of u minus u x square sin pi x as it is into differentiation of v, which is a 2x, okay, upon v square, that means x square raised to 2, okay. V square means x square raised to 2, okay. This one is the differentiation for f dash of x, okay. Now go for more simplified form of this f dash of x, that we can define the local maxima or minima over here, okay. Now here we can see put f dash of x is a 0, so f dash of x, if you want the local maxima minima, then we put the f dash of x is 0. So 0, which is equal to x square into pi cos pi x minus 2x sin pi x, okay, upon x raised to 2 to the power 2. That means when base is same, we add their power, okay, x raised to 4, okay. So here we can see in our question, sin pi x by x square define only when x is bigger than 0. So this x raised to 4 never 0, okay. X raised to 4, it never become 0. Why it is never 0? Even if it is goes to 0, then we say that our function cannot define, okay. And one more condition, it is given in question, x is bigger than 0. So if x is bigger than 0, x raised to 4 non-zero, okay. If this is non-zero, then this term equate to 0, okay. So how can we write next step? Take here cos pi x common from this one, okay. So what we will get, so take that x common first and cancel it with this x, okay. So that means we will get here pi x cos pi x minus 2 sin pi x upon x cube, okay. So next term, which is the pi x into cos pi x minus 2 times sin pi x upon x cube, okay. The fourth power here get cancelled with above x, okay. So here we take a cos pi x common from here, that we can find easily root of our equation. So cos pi x common from here, it is a cos pi x common here, okay. Under bracket it will remain pi x itself minus 2 times sin pi x, and take cos pi x common from sin pi x. So we have to multiply cos pi x divided sin cos pi x. So you will get the cos pi x outside and another cos pi x to denominator. So sin pi x upon cos pi x, which is a tan pi x, okay, upon x cube, okay, which is equal to 0. Okay, so as we have x cube non-zero, okay, as we have x cube non-zero, and above term above whole term it equate to 0. This is non-zero, that means the multiplication of this term need to be a 0. That means cos pi x multiplied by pi x minus 2 times tan pi x, which is equal to 0, okay. So what I have done, so this bracket, okay, pi x minus 2 times pi x, okay. So if this term which is equal to 0 and x cube is non-zero, that means numerator need to be 0. So 0 upon something is 0, okay. So this way this one will be whole. So if their multiplication is a 0, then we write whether this one is 0 or this one is 0, okay. So if cos pi x 0, then whole term becomes 0, or pi x minus 2 times tan pi x 0, then whole term become 0, okay. That means we have our option here, whether this is 0 or this is 0, okay. So let's find out these two options. First is a cos pi x is a 0, okay. If we have cos pi x 0, now tell me the what value for cos is a 0. We learn it into the trigonometry. So cos theta is a 0 when theta, which is equal to 2n plus 1 multiplied by pi by 2, okay. So this is the value for theta, where cos theta 0, okay. So that means all values for theta which running from 0 to n, okay. So for these values cos pi x is a 0, okay. So the value, if you run from all values from 1 to n, okay, then we'll get the cos 2n plus 1 pi by 2, okay. So when cos theta 0, theta need to be a this thing. So okay, then pi x need to be a 2n plus 1 pi by 2, okay. So we want the all possible value for x where cos pi x is a 0. Okay, so this pi get cancelled with this, so I got the possible value for ax, which is the 2n plus 1 pi by 2. Okay, and n running from 0, 1, 2 and so on. Okay, so the value for x, which comes like x is going to put x is 0, then we'll get the 2 into 0 plus 1 by 2, so which is 1 by 2. Put x is a 1, 2 into 1, 2 plus 1, 3 by 2. X is a 2, 2 to the 4 plus 1, 5 by 2. X is a 3, 3 to the 6 plus 1, 7 by 2. X is a 4, 2 4 the 8 plus 1, 9 by 2, and so on. There are infinitely many values. Okay, just we need to understand which type of the values are coming for x. Okay, so these all are the value for ax where cos pi x is 0. Okay, so our first half solution it is solved over here. So I got the point cos pi x where x is a 0. Okay, now what happen if I take cos pi x as a non-zero? If this is a non-zero, then leftover option is here pi x minus 2 times tan pi x 0. Okay, that means pi x minus 2 times tan pi x, which is equal to 0. So left option here pi x minus 2 times tan pi x is 0. Okay, so when this term is getting 0, don't know, because this is quite confusing term, we cannot say directly. Okay, so pi x minus 2 times tan pi x is 0. Okay, so for that we have to simplify this term. Okay, so take pi x, it is here, so we'll get the 2 times tan pi x, which is equal to pi x. Okay, now still it is difficult to find out the value. Okay, so for finding such a zeros of our trigonometric identities, we have to plot the graph. Okay, because graphical presentation it is very much useful for finding such solutions. So if you're going to find out the value for what value for pi x, you will get the tan pi x, tan as a pi x. So it is literally difficult. So that's why what we need to do, we have to plot the graph for tan theta, obviously, which is a 2 tan theta. Okay, and then plot the graph of a pi x. Okay, plot the graph of a 2 tan pi x, plot the graph of pi x. Okay, and find out their intersection point. Okay, what we have to do, we have to find out intersection point. Okay, so we have to find out the intersection point between these two graphs, and wherever the point which intersect, these are the exactly solutions, or these are the exactly solution of our pi x minus 2 times tan pi x is a 0. Okay, and if you don't know how to plot the graph, I already uploaded amples of the video on my channel. Okay, so these are very much useful that you can plot the graph. Okay, there are some other textbook also there that you can use these textbooks for understanding how to plot the graph. Or even if you are from 12th standard, I uploaded the lecture series on real analysis. So there I uploaded how to plot the different graph, modulus function, step function and other function. Okay, so you may refer these videos for understanding the graph of functions. Okay, and even after, if you found difficult how to plot the graph for difficult function, let me know in a comment section. Okay, we'll go through this. And one more thing is that to plot this graph in a Python, okay, Python language, that I will explain. It is very easy to plot the graph in a Python language, that you can visualize difficult graph over there. That I will start in few days. I will start shortly the lecture series on Python language. Okay, where to plot the graph, go for difficult calculation, finding the differentiation, integration, everything I will explain there in Python. Okay, so I will start that lecture series. And now for here, so I got the tan pi x is equal to pi x. We want the solution for this one. So now let's plot the graph. So here we can see I got the two values for tan pi x, which is one cos pi x is equal to 0, and second pi x minus 2 times tan pi x 0. Okay, because it is local maxima minima, that's why we have to take f dash of x 0. Okay, so here I got the two value cos pi x and pi x minus 2 times tan pi x 0. Okay, so cos pi x 0, I explained already earlier what the value for cos pi x 0, and pi x minus 2 times tan pi x, we have to find out the values. Okay, so this is the value for cos pi x, and we have to plot the graph for y is equal to 2 times pi x and y is equal to pi x. Okay, now let's find out the graph for these two functions and find out where these 2 points are collides. Okay, wherever the points are collides between this first and second graph, these are the exact solution of our trigonometric identity. Now here in our graph, we want the y which is equal to pi x. Okay, we want the first graph y which is equal to pi x. Whenever you substitute the value for x, you will get the y. Okay, when x is a 0, you will get the y 0. So first point it is coming here. Okay, when x is 1, you will get the y pi. Okay, that means it is a 3.5 value for pi is a 3.14. Okay, always remember 3.14 something is there. When you take x is a 1, you get the y 3.14. So x is a 1, y will get the 3.14. Okay, so the values for the graph, which is whenever you put x here, you will get the y here. Okay, this is the way you will get the graph. Okay, y which is equal to x. Okay, this is the graph of y which is equal to x, and when we multiply pi to the x, that graph it goes little to the side of x. Okay, it is little to the side of, because the values of y are x is increasing. Okay, y is increasing when we multiply pi to x. Okay, so this graph it goes to little this side of a y. Okay, y which is equal to pi x. That you can go for just a general calculation for our graphical presentation. Okay, so for finding each and every point separately, it is quite a bit time taking. But if you fail that, you may go for this way. Okay, so this is the graph y which is equal to pi x. I hope you all have understood. Okay, it's quite easy graph that I just drew it here. Okay, so you may can see into my upper side of screen there I already plot the graph over here. Okay, because it's quite time taking, that's why I already drew that graph. Now here in my second graph, okay, we want the second graph which is equal to, we have second graph we have here y which is equal to 2 times tan pi x. Okay, so we have to draw the graph of a tan pi x and need to multiply 2. Okay, so we know that tan pi x is having graph like this in interval, like this interval. Okay, so if we take origin over here, so tan graph is going like this. Okay, so again another graph which is going like this, again another graph which is going like this. Okay, this is the graph of a tan y is equal to 2 times tan pi x, as you can see in my screen also. So we got the graph of y is equal to pi x and 2 times tan pi x. Okay, this is a general graph, I drew it here. Okay, now and we want the collision point between y which is equal to pi x. This is the equation of y which is equal to pi x. Okay, and this is the graph of y which is equal to 2 times tan pi x. Okay, so this is a graph y is equal to 2 times tan pi x. Now collision point between y which is equal to pi x and 2 tan pi x, where it is coming, it is first 0 0, another point it comes here. Okay, so this first it goes to 0. Okay, second collision point you will get that second point y is equal to pi x and tan pi x. Okay, this is the graph of tan pi x. Okay, this is the first point you will get the collision point. Okay, so here it is the first point for first solution of our trigonometric function. Okay, y is equal to 2 tan pi x and pi x. Okay, which is equal to pi x. What we have solution 2 tan pi x which is equal to pi x. This is the trigonometric function we do have here, and we want the solution for this function. That means we have to find out these two graph and we have to find out collide points. Okay, where this function collides. So here we can see that the first graph the collide with this tan pi x. Okay, it is here. So first x coordinate here, y coordinate here. Similarly you will get the second point somewhere here. Okay, this is the collision point between these two graphs. So first point x here, y point here. Okay, this is the way. So you can see it into my screen also. Okay, now here let me explain in detail. So I drew this graph over here. You can see this graph. So in my graph, I plotted the point where cos pi x is 0, which is 1 by 2 first point, second 3 by 2, which is 5 by 2, 7 by 2, 9 by 2, and so on. Okay, these are the point which is coming from cos pi x. Okay, now we want the point here 2 tan pi x which is equal to pi x. Okay, 2 tan pi x which is equal to pi x. That means the point where pi x and tan pi x is collides. Okay, so here first point it is here, second point it is here, third point it is here, fourth point it is here. Okay, the collision or the intersection point between this pi x, y which is equal to pi x, and y which is equal to 2 tan pi x. Okay, it is over here. So first point it is here, second point it is here. Now next point, third point it is here, fourth point it is here. Now fifth point it is 5 by 2 here, sixth point it is here. So 1 by 2 first point it is for cos pi x. Okay, and x1 y1 this is the collision point for intersection point for 2 tan pi x which is equal to pi x. So if I got the first point for cos pi x and second point for y is equal to tan pi x is equal to pi x. Okay, so first point here, second point here. third point here, fourth point here, fifth point here, sixth point here, seventh here, eighth here, and so on. Okay, that graph goes to infinity here. So we can see these general values are coming like this. Okay, now using this graph we have to figure it out options. Okay, our first option, it says that whether xn plus 1 minus xn which is bigger than 2. Okay, so first point is what we have here, xn plus 1 minus xn bigger than 2. Okay, we have to find out whether xn plus 1 minus xn which is bigger than 2 or not. So to visualize the first option, okay, xn plus 1 minus xn is bigger than 2 or not. Okay, that means we have to find out xn plus 1 and xn. Okay, now here we can see that xn plus 1, so here we can see we have xn plus 1 minus xn have bigger than 2. Okay, so this is our first option. It says given in our first option for all values of n. Okay, now let's verify first value. Can it possible for the value for n is equal to 1? Then we check for n is equal to 2. If it hold for first 2 3 value, then obviously it will hold for another value. Okay, put n is 1, that means x2 n plus 1, that means x2 1 plus 1 is x2 minus x1 bigger than 2. Okay, can it possible the value for x2 minus x1 is bigger than 2? Okay, now here we can see the value for x2 we have here this point. Okay, x2 is here, that means between 2 and 2.5, but not, it is closer to 2.5. Okay, exactly not 2.5 but closer to 2.5. Okay, now it may be considered, we consider as x2 as a 2.4 or smaller than 2, exactly 2.4. Okay, because maybe it is not a 2.5. Okay, the value for x2 it is not 2.5 because it is closer to 2.5, so we may take 2.4 or 2.678 something this. Okay, minus x1. So what is the value for x1, which is 1 by 2. Okay, but we cannot take 1 by 2 which is 1 by 2 or smaller than 1 by 2. Okay, 1 by 2 or smaller than 1 by 2, this is the intersection point over here. So 1 by 2 or smaller than 1 by 2, that means it is smaller than 0.34 something like this. Okay, if you take 0.34, okay, or this is maybe bigger number, so it's surely coming bigger than 0. Okay, so 2.56 minus 0. 0 point something. Okay, 0.4, so it is bigger 2 point something. If it comes 2.234, it is coming bigger than 0. Okay, so it is hold for x2 minus x1 here. Similarly do it for y2 minus x, again n is equal to 2, x3 minus x2, so x3 minus x2 can we write bigger than 2? Let's verify for this one also. So if we take approximate point for x3, so here we can see we'll get the here between 3 and 3.5. So it is closer to 3.5 but not 3.5. So we may take it is closer to 3.5, means we take a 3.45 46 like this. Okay, but not 3.5. so we subtracted 2 from our between the point 1 and 3.2. Okay, so x2 minus x3 minus x2. Okay, x3 minus x2. So what is the value for x2? It is here, it is between 1 and 1.5, that means it is smaller than 1.5. It is coming like 1.2 1.3 like this. It is obviously bigger than 2. So whatever the value for you select for xn plus 1, and if you subtract the previous value from xn, you surely get the value bigger than 2. Okay, so this one is hold over here by using this graphical presentation. I hope you all have understood. So even if you confuse for any other point, let me know in comment section. Okay, so quite confusing to understand but easy. Okay, think about it the way that JEE Advanced want. Okay, so that means we have first point x1 here, x2 here, x3 here, x4 here. Okay, like this way the point will be get increasing. Okay, if you consider the point x1 here, then x2 you take it here. Okay, if you consider the point x3 here, then you consider x2 it is here. Okay, the relation between the 2 points. Okay, because the interval changes between over here. Okay, so this is the first, this is the second. Okay, so you have to take as per the interval. Okay, so one interval ends here, another interval starts here. One ends here, another starts here. Okay, so you have to think by this way. So now here we can see our first option, xn plus n, xn plus 1 minus xn bigger than 2 for all values of n. The first option is correct over here. Now second option, it says that xn which belongs to 2n plus 1 by 2. Okay, Now let's verify, can it possible xn which belongs to 2n and 2n plus 1 by 2 for all values of n. Okay, so we have to check this option. Okay, this option we have to check, xn belongs to 2n comma 2n plus 1 by 2 for all values of n. Now n we may select anything, so can we take x is 1? If n is 1, then we write x1 belongs to 2 comma 2 into 1, it is a 2 plus 1 by 2, which is a 3 by 2, 5 by 2, sorry, 4 1 in the 2 to the 4 plus 1, 5 by 2. Okay, so can we write x1 point which belongs to 2 and 5 by 2? Now let's verify, where it is a 2 and 5 by 2, here it is a 2, here it is a 5 by 2. Okay, so x not, it is here x1, we can write, can we write x1 which is belongs to 2 and 5 by 2? Yes, it is here possible, because 2 and 5 by 2 contain this point x. Okay, so if I put n is a 1, x1 belongs to 2 and 5 by 2. If I put n which is equal to 2, then can we write x2 belongs to 2 to the 4 comma 2 to the 4 plus 1 by 2, that means 2 4 the 8 plus 9 by 2. Okay, so can we write x2 which belongs to 4 in comma 9 by 2? Let's verify. So 4 and 9 by 2, it is over here. Okay, this one is x1. Okay, this one is, after taking one gap you will get the x2. Okay, so can we write x2 belongs to 4 and 9 by 2? Yes, it is true here. Here we can see in our graph. Okay, in our graph x2 it is belongs here. Okay, 4 and 9 by 2, between 4 and 9 by 2 x2 is lies here. Okay, similarly any value that graph goes to infinity. Okay, so similarly if you take any values for n, you will get that n which belongs to some certain interval. Okay, 2n comma 2n plus 1 by 2. Okay, so it says that our option number B, which is also true. Okay, quite easy option, just see from our graphical presentation. Okay, now option C, can it be possible modulus of xn minus yn bigger than 1 for all values of n? Now let me explain over here. Modulus of xn minus yn. Okay, so modulus of xn minus yn which is bigger than 1, can it possible? Now here the values for x and n and yn, how can we define the value for xn and yn? So xn is the value which is coming from the cos theta which is equal to 0, which is 1 by 2, 3 by 2, 5 by 2, 7 by 2 and 9 by 2 and so on. Okay, so if I consider x1 which is a 1 by 2, then yn which is y1 which is coming from the values of pi x minus 2 tan pi x. Okay, that one. Okay, so that the value will get it here. Okay, which is somewhere between 1 and 3.2, but not 3.2. Okay, so we'll get the 1.4 something. Okay, so 0. It is smaller than 1 by 5, means 0.4, 0.3 something like this. Okay, so x1 minus y1, 0.3 minus 1.4. Okay, something like this. Surely it is coming bigger than 1. Okay, because these are not closer to 1.5, 1 by 5, 1.1 by 2. Okay, so that means 0.4, 0. Something like this. Okay, and minus 1.4, 1.4 point something, it's like this. Okay, this value is closer to this one. Okay, 1.5, like 1.9 something like this value is closer, okay, than this one. So if this is closer, then we write this subtraction is bigger than 1. Okay, so xn minus yn which is bigger than, not for only this point, you may take some other point too here, 3 by 2 minus this point, okay, 1.5 minus, it is something like over here. Okay, so you will get the subtraction between this and so on. Okay, you will get the xn minus yn, it is always bigger than 1. Okay, so exactly our option number C, it says that xn minus yn is bigger than 1. Okay, okay, that means modulus of xn minus modulus of yn is bigger than 1. So can we expand this modulus? Okay, so modulus of xn minus modulus of yn which is bigger than 1. Okay, 1 or bigger than 1. Okay, 1 or bigger than 1. So we write bigger than 1. Okay, so take this one over here. Okay, so what we will get here, we'll write this as modulus of xn is bigger than, take negative modulus of yn here, 1 minus modulus of yn. Okay, 1 plus modulus of yn, negative yn, it become positive yn. Okay, that means we have here modulus of xn is bigger than 1 plus modulus of yn, that means xn is bigger than 1 plus yn. Okay, xn is bigger than 1 plus yn. So what we do, if 1 plus yn is smaller than xn, surely yn is smaller than xn. Okay, so if we add one term here, we remove one term from this term, it will be always smaller than xn. Don't get confused. Let me explain one more time. If xn is bigger than 1 plus yn, okay, so this term is smaller than xn. What happen if we take something out from this term? This term will go more smaller. This term will go more smaller than xn. Okay, so this one it will be hold. If xn is bigger than yn, then we write x1 is bigger than y1, x2 is bigger than y2, x3 is bigger than y3, and so on. Okay, I hope you all have understood this relation. So this relation we have to apply over here. So x1 is bigger than y1, we got it here. But in our option number D, which we have given, x1 strictly less y1, which is not possible. We got the some other way. Okay, x1 bigger than y1. Okay, so option number D, which is discarded here, that violate the property of our option C. Okay, so these are the A, B, C, D 4 options. Okay, that within that A, B, C true and D is wrong. That I drew that graph in a upper side of screen. You may see that graph, it is properly visualized, visible there. That how can we define the point? Okay, so this is the very easy question, just graphical based question is this one. We have to find out the solution for two terms, and we have to find out where these terms interact. Okay, the intersection with these terms gives us the 4 options, true or not. Okay, so I hope you all have understood my today's lecture. It is very easy solution. Even after, if you found anything difficult, let me know in comment section. I will come up with some other videos. So thank you everyone. Thank you for my today's lecture.